Hello, my name is Rich Howard, owner of Architectural Builders Supply. In this video is to bring you a closer look at the Rockwood number 2848 automatic flush bolt with a bottom fire bolt. And this is a confluence of parts that will allow you to be compliant with a fire rated requirement in a particular application. Let's take a look at what this is. So the business end of this, and this is going to be, this would be an automatic bolt, not self-latching, but this would be an automatic bolt that you would see at the top of the door, and it has a bolt, doesn't have a latch. They can do a self-latching model of this as well. You're going to need other hardware would go along with this, and we'll get into that in a moment. So this is an automatic flush bolt. Trigger, when it's depressed by the action of the door closing, throws that bolt up, as you can see. Okay. This has an override mechanism where if there is a misalignment or some reason that the bolt will not go up, I'm going to use my palm to capture it there. It will override, as you can see there. Otherwise, the healthy operation is like that. Okay. This is in the 626 finish, which means satin chrome, and this can be done in, of course, all of the common finishes that you would do, trim and auxiliary hardware too, finish hardware, like flush bolts. And this is going to come with, won't be too much included. You're going to have, obviously, a strike. You're going to have a scar plate, and then you'll have the face plate. Then your fasteners. Those are just going to be typical screws. They're going to give you a couple of plastic anchors, and that would be for the, which if you were using it in a bottom application with a self-latching at the top, you'd use those plastic anchors. You might say to yourself, where will I use these plastic anchors? Nowhere in this application. Absolutely nowhere. You would use it in a application where this was at the bottom of the door. Well, you're doing a bottom fire bolt here. So you're going to have a faceplate, and there it is. Okay, it's got a peel-away paper film. That goes right on and covers that up and gives you the finished look. Obviously, as your finish changes, all that changes is the exposed hardware. This is going to be the typical 6 3/4 by 1, 6 3/4 tall, 1 inch wide. That'd be appropriate to call it a scalp plate. Scalp. Scalp plate is also known as that thin piece of architectural metal on the front of a rim or a mortise cylinder. Scalp plate. Call it a faceplate as well, I suppose. Then you're going to get the strike, and that's going to be 2 1/4 by 15/16. Typical common prep. You'll have that prepped to the header of your steel frame. I would imagine it's a steel frame because you have a fire-rated door. Then you're going to have your scar plate, which is what I'm calling it. Rockwood calls it active door strike. Sure, active door strike. Now what happens is this gets attached to the active door. This has a height of 1 1/4 and then an overall width of about 1 13/16 inches. Here's the action. This is your inactive door. You're going to need a coordinator, would be certainly what would need to happen. And your coordinator is going to force your active door to stay ajar until the inactive comes into the closed position. Then at that point, your active door will then come, and that scar plate or the active door strike mounted to the active door will hit that latch, and the concept is it will simply push it in and open, and that plate is provided so that you don't have degradation to the edge of the door, obviously. So that's what that active door strike is for. You're also going to get the mounting plate. This piece of material is going to be installed in the top channel of the door. You might probably make, well, your factory is probably not going to require this piece and will already have the door manufactured for the 2848. but this is meant to go into the top of the door, and then your bolt, of course, rides in that preparation, and it's square, as is the bolt, so that it doesn't rotate over time. Okay. Once upon a time, customers would call and say, yeah, my flush bolt doesn't work anymore. It fell in the door. Well, what happens over time is that just continues to rotate. Believe it or not, you say to yourself, well, how could it rotate? Well, they do, and it very likely can be caused by just simple vibration. The doors being closed, general vibration. The weight is up here. That's going to serve to work its way down like this. And an interesting fun fact is it was found with very old safes made decades and decades ago, that were installed in seagoing vessels. The wheel packs in a safe lock, let's say there are 3 that are in there could be more, they're weighted. Well, they're not weighted, but imagine a donut-shaped piece of metal, and there are 3 of them stacked together. It doesn't matter the quantity, but they have a notch, for lack of the proper term, cut in them, so that it's the gate, so that the fence can lock into the wheel pack so that it can pull the bolt back when the proper combination is dialed. Well, they found over time that that donut isn't the same weight as you measure it around, and what would happen over time is the gates would all align at the top. You could pull the bolt and the fence would come and lock in and you can open it up. So things happen because of vibration and movement, and that's probably why that would happen. So that's why it's crucial to have a guide that will prevent that, because what will happen is it will not work eventually. So if you prep a door for a flush bolt, be sure that you're using a guide, is the moral of the story. Now you're going to get the fire bolt, and this is a doodad that's a relatively recent invention. It's got to be 25 years old at this point, would be my guess. And you're going to have, in essence, you've got a plastic plug. That's going to go into the active door. You're going to drill a hole and you're going to snap that in place. That's all you're doing. Then you've got the fire bolt itself. This is going to be drilled into the inactive door and left in place. So they're going to look just like this. When the door hits a prescribed temperature, well past any temperature that a human being would be standing there, 160 degrees, 200 degrees, whatever it is, and I don't see the temperature listed, but we'll investigate that. When that happens, there's going to be a projectile that shoots out of the end of the bolt. It will burst through this plastic cap and secure all that together, giving you a situation in a fire-rated application whereby you're compliant with the doors staying latched. So a pair of fire-rated doors must be self-closing, they must be self-latching, but they must stay latched for the duration of the fire test. So adding a bottom fire bolt gives you the ability to keep those doors latched at the bottom of the door, when all you are really doing is latching the top of the door up at the header. Well, I've never really seen a firebolt test done, but you can imagine without any sort of latch in the bottom quadrant of the door, those doors could easily deflect out, and obviously it would cause a failure of the test. But apparently when you have a firebolt principle and they lock together at that bottom third of the area, it passes the test. So this 2848 includes the firebolt, okay? Be very typical. Now, where would you use this sort of application? I would say that you would use it in a pair of doors that are fire-rated. You need to have movement through the doors. When you open the active door, you can immediately push the inactive door open. Active door opens. The inactive door is unlatched because your active door is now open. You can easily push that door open. Let the doors go. Doors will close. Coordinator will time the closing. Inactive first, then active. You're code compliant. You'll see this application I have seen this application in instances where you have an exit device on the active door, but the occupancy, by the quantity of occupants and the formula by which exit devices, the quantity of exit devices and exits themselves are derived do not they do not mandate that exit devices be on both doors. So if you had, I'd have to pull out my code book and go through and refresh my memory. There's a formula by which quantity of people and then clear opening width tells you not only how many exits but how they're equipped. So if the formula tells you only one door is required based on your opening width, then you have an exit device on one door. Well, it's still a fire rated door. So what do you want to do? You want to put exit devices on both doors? Great. No problem. Love that. Get fire rated exit devices. You could also put an automatic flush bolt and a fire bolt to make that happen as well. You can have nothing on the inactive door that looks like a trim. You can have nothing. No dummy hardware, nothing. And that's how that works. And that is code compliant. Last time I sold a set like this, it was literally to a pair of doors in a parking garage. Same scenario. Didn't require exits on both doors. And that's what the client wanted, and that's what we did. Actually, we were matching existing, and that's exactly what it was. Now, there is a link below this video to a document called Template. Before we get to that, let's go over the extended description. Automatic flush bolt with bottom fire bolt. Satin chrome finish. You can do your brasses, your bronze, your chromes, oil rub bronze. Powder-coated finishes, absolutely. Black, certainly. I think red and white now are available. They can powder coat that exposed hardware. You've got your fasteners. It's rated on metal doors, not wood doors, only metal doors. If you have a wood door application, you need a different bolt. You can make this work on a wood door, but it's not listed for use on a wood door. It's only been tested on steel doors. Non-handed, low 5 pounds of closing force. That means that your active door, equipped with a door closer, ought to have enough torque, so to speak, spring power to get that pushed in and latched. Fully automatic, opening the active door, retracts the top bolt. Override feature, we talked about that. If I restrict that, it's going to override. Bolt rod is adjustable up to 1.5 inches. You can take that sucker and you can thread it to account for any circumstances or conditions that you're dealing with. What I mean by that is it's not going to happen at the top of the door, but if this was being used at the bottom of the door, you might have an unusual circumstance, maybe an unusual undercut, that you need that bolt to move a little bit more than necessary. The problem with that is you can only have an undercut up to a certain value, and you have to have penetration of the bolt into the strike of a minimum value. So the fact that it's adjustable is good, but the guidelines in terms of undercut and then penetration of the bolt into the strike are still fixed values. Thermal lock automatically locks the inactive door under high heat conditions. Don't think so. Not on this one. Let's take a look at that. So I took a little break there and called the manufacturer. The thermal lock location eluded both me, customer service, and one of the engineers at the factory. And I'm told that there is a person there who knows the answer and will be communicating back to me. For right now, I can see no evidence of how this is going to work. Obviously, something has to lock this up. I'd like to think that right at the tip of my finger, it will force it locked in the up position right there, which would certainly do it, but I don't think there's any sort of intumescent that's in there, nor do I see, it's an academic question, really. When we get the answer, we'll update that. The catalog clearly states there's a thermal lock. The gentleman I spoke to says that he knows there's a thermal lock, but could not demonstrate its location on the telephone. So, moving to the template that's there, which is also, of course, included with the paperwork, we are looking at all of the dimensional properties of the flush bolt itself, and most notably, we've covered the dimensions. You can see all the dimensions. That's important because it will certainly illustrate to the person making the preparations in the door what is required for the hardware in order for it to be correctly prepped in the edge of the inactive door. What's important for you to note, I think, if you're unfamiliar with flush bolts, is the 12-inch dimension in the lower left-hand corner. This is a 12-inch flush bolt. It happens to be, of course, 6 3/4 by 1. That's important, but it's a 12-inch flush bolt. The top of the door or the bottom of the door to the center of the faceplate is 12-inch. That's how we call. What size flush bolt do you want? We don't first mean this and this, even though we do. First dimension is what's that distance? Is it 12-inch? Is it 18-inch? Is it 24, 30, 36, and so on? 12 inches standard for doors that are 6'8" and 7'0". If you get to an 8-foot door, you probably need a longer rod, and you can order longer rods with these from the factory. You wouldn't need it with an automatic flush bolt. In fact, it wouldn't really matter because you never have to reach this. But in the realm of flush bolts where they're manual, or it is a 28-48 used at the bottom, and then the self-latching at the top where you depress the trigger, you're going to want to be able to reach up and be able to actually activate that. So, you know, if you have a 7'6" door, you go to an 18-inch. If 7 foot at 12 inch is your guideline, add the corresponding rod length as your door height increases. So be mindful of that. They show you where they want the bottom fire bolt installed. That's quite near to the floor, and that's the way it was tested. I would very much recommend that it be installed exactly where it's been drawn. The truth of the matter, however, is that prep's going to need to be done at the factory because the size of those holes will be greater than what would be permissible to drill into the door. So they have to be drilled at 6-inch. Someone performing a fire door assembly audit, which is mandatory in 4 occupancies on an annual basis per code, may very well be looking for deviations like that. Because the directive is under a fire door audit, or an inspection, I should say, what do the installation instructions say? They clearly indicate 6-inch. As an interesting aside, if you have a heavy-duty door closer with a plastic cover, and that plastic cover has been taken off and thrown away on a fire door, if that cover is missing, would you think that the door is still compliant or out of compliance of the fire rating? Turns out it's out of compliance. That plastic cover does nothing except melt in the first 2 minutes of a fire test, right? However, the installation instructions specify install the cover. So that's why it's important to adhere to that 6-inch dimension. This is for a steel door, so talking about the preparation, that would be something done at your factory. Whoever is making the door and frame for you, they will want to work with this template. You would forward that paperwork to them in order to get that door manufactured correctly. There's also a link below this video to the product catalog, and that's an overview of the flush bolts from Rockwood along with their coordinators. And again, coordinators are typical pieces of equipment from Rockwood and used, in your installed pairs of doors. Okay. Finally, there's a link below this video to the manufacturer's page where you can pull up not only all of the Rockwood products that we sell, but also as a link, there is a link to the manufacturer's website, as well as a link to the full product catalog. And again, when I get that answer on the thermal lock override feature, I will amend the extended description to make that more descriptive. Any questions on the 2848 by Rockwood or any other Rockwood product, please feel free to reach out to us. And thank you.